Hello everyone. So today we're going over to P7 here. P7 is rational expression. Rational expressions. Last time we go over the rational expression. I gave the definition of rational expression, and also I give some example for rational expression. Also, I go over the domain of algebraic expression, and I give some example for how to find the domain of some algebraic expression. Then we move over how we simplify rational expression. I gave some example, and I start for talking about multiplying and dividing rational expression. And I gave example for multiplying rational expression. The left here is dividing rational expression for this part of this section. So here multiplying, dividing rational expression. So we're going use some properties. The property said the property said if I have two fraction, this fraction is a over b divided by c over d. So this is equal a over b multiplying by c over d, and the equation here, the final answer. So here I can get, if I have again, if I have a over b dividing by c over d, so I have two fraction expression. So this is equal a over b. We change the divide to multiplication, then we have to flip this fraction. So this fraction is d over c. And again, like last time, so two fraction, and between these two fraction is multiplication. We multiply the numerator together and the denominator together. So here I can get a times d over b times c. A times d over b times c. This is the property for dividing rational expression. So let me give you example for this. So here example. Suppose I have x minus 4 over x square minus 4 dividing by x square minus 3x minus 4 over x square plus 5x plus 6. So here again, if I have x minus 4 over x square minus 4, and here we have x square minus 3x minus 4 over x square plus 5x plus 6. So this is equal. So first of all, I prefer for a question like this to simplifying the numerator and the denominator for the first fraction, and the same things for the second fraction, simplifying the numerator and the denominator for the second fraction. So now I can get here x. What is the simplifying for this? What is the factor for? I mean, like, what is the simplifying for x minus 4? Or what is the factor for x minus 4? I mean, yes, the same things exactly. So it will be the same things, x minus 4. And what is the factor for the denominator?
X minus 2, x plus 2.
Exactly. Would be like x Eric, it's not, yes, 2. So x minus 2 times x plus 2. Here we have divide by. Now we have to factor this numerator, and the same thing is factoring the denominator. What is the factor for this denominator?
X minus 4, x plus
X minus 4 and x what?
x plus 1.
X plus 1. So actually we're looking for two numbers. This the multiplication of these two numbers is minus 4, and the sum of these two numbers is minus 3. So the best two numbers that work with to factor this numerator is the minus 4 and plus 1, because minus 4 times 1, they give me minus 4, and the sum between minus 4 and plus 1 is minus 3. So x minus 4 times x plus 1. Mohsen, he said x plus 4 and x minus 1. This will not work because the 4 and minus 1, the multiplication, they give me minus 4, but the sum between the positive 4 and minus 1 is plus 3. Is not the same as minus 3, this number in the middle. So this will not work, Mohsen. So here now, dividing by the denominator. So what's the factor for the denominator here? What is the factor for this one? X squared plus 5x plus 6. We're looking for two numbers. The multiplication of these two numbers, they give me 6. And the sum of these two numbers, they give me 5. Yeah, this is correct, Eric. Eric said is x plus 3 and x plus 2. This is correct because 3 times 2, they give me positive 6, and the summation between 3 and 2, they give me the 5, the middle term. So here will be x plus 3 times x plus 2. Now we're doing the same things for this property. We put the first fraction without any change. The first fraction, so the first fraction, and the second fraction, we have to flip the second fraction, and between the two fraction is multiplication. So now we can get x minus 4 times over x minus 2, x plus 2, and the symbol here is, instead of dividing by using this property a over b divided by c over d, we have to put the multiplication sign. Now we have to flip these things. The numerator goes to move down, and the denominator move up. So now can I get x plus 3, x plus 2, and this is down, x minus 4, x plus 1. Now we can cancel whatever the common factor between the numerator and the denominator. Which term we can cancel from the numerator and denominator from this two fraction? What can I cancel?
X minus
X
4.
mark.
Yes, x minus 4 with x minus 4, they will cancel. What else I can cancel?
X plus 2.
X plus 2 with x plus 2, this is correct. What about, what else? Can I cancel x plus 3? There is a common factor in the denominator for x plus 3. No, I cannot cancel x plus 3. So I keep it the same thing. So exactly, Mohsen, x plus 3. So I can't cancel it, I put it. And here, whatever left, I put it down. So here left x minus 2, x minus 2 times x plus 1. And this is my final answer. So here you have to make sure you can cancel whatever common factor between numerator and denominator after you change the sign from dividing to multiplication, and after also you flip this fraction. So you cannot cancel before you change the sign from dividing to multiplication. Any question for this example? Okay, so it's clear, easy. So you have to put again the first fraction. Here you have to flip the second fraction. Before you put everything, I prefer to factor the numerator and denominator from the first fraction, and the same things for the second fraction. Then you have to change the sign. When you do like dividing, you have to put the first fraction multiplying the second, flip the second fraction. Then we can cancel whatever common factor between numerator and denominator. So now the dividing rational expression is finished. Now we're going over the adding and subtracting rational expression. So here adding and subtracting. So here adding and subtracting rational expression. Subtraction rational expression. So the most idea here for this part, we have to find the common factor between common. I mean, you have to find the common denominator. So here, the best or the most idea is to find or to finding the common denominator. What does that mean? Means after I find the common denominator and I have and then use the property. The property said if I have two fractions, then use this property. The property said if I have two fractions, this is the fraction, here's the fraction. So first of all, I have to find the common denominator. Then the denominator are equal. So the fraction would be like a over b, I mean a over c plus b over c. So the denominator are equal, the same. Why? Because we find the common denominator. So the c are equal. So now this is equal. We just adding the numerator and the numerator from the first fraction and the numerator from the second fraction. So here I can get a plus b over c. So the question now, how we can find the common denominator? So the best things to find the common denominator is by using the least common denominator. We use these things in the first section in this book. So the common denominator is found by the least common denominator. Least common denominator, we spoke about this in the first section in this book, but I'm going to give you an example and then I will remind you how to find the least common denominator. Okay, example for this. Any question for the definition? Okay. So let's go to the example. Here's the example. I have 3 over x plus 1, x minus 1, sorry, plus x over x plus 2. Now, the question is, find the sum between these two fractions. First of all, we have to find the least common denominator, like I said before, least common denominator. So to find the least common denominator, we have to factor the denominator for both of the fraction. So the factor of x minus 1. What is the factor of this x minus 1? What is the factor for this denominator?
X minus 1.
X minus 1, the same. And the same things, we factor the second denominator, the factor of x plus 2. What is it?
X plus 2.
Is the same, x plus 2. So we factor the denominator from the first fraction, we factor the denominator from the second fraction. Now, we did not find any common between these two fractions, so there is nothing to cancel each other. Now we go to the first fraction, we're multiplying by the factor of the second the factor of the second denominator in the second fraction. So we're multiplying by x, the factor of x plus 2, we're multiplying by x plus 2. So this, we're multiplying both sides by x plus 2 and here by x plus 2. We go to the second fraction. In the second fraction, we multiply by the factor of this denominator. And the factor of this denominator is x minus 1. So we're multiplying this by x minus 1 and multiplying this by x minus 1. So now we get new fraction. So the multiplying for this one is we have to distribute inside the parentheses. So now can I get 3x plus 6 because I distribute inside the parentheses. And here I can keep it the same things. X plus 2, x minus 1, adding by x squared, because I distribute the x inside the parentheses again, x squared minus x. And the denominator is the same, x plus 2 times x minus 1. Now look, both of the denominator are equal, x plus 2, x plus 2, x minus 1, x minus 1. I mean, we can use the property in the previous, the same c for in the both fraction, a over c plus b over c. Both of them, they have the same c. So here, x plus 2 times x minus 1 is the same in the second fraction, the denominator in the second fraction, x plus 2 times x plus minus 1. So this is mean we can add both of numerator in the both fraction. So this is equal. Now this is equal 3x plus 6 plus this one plus x squared minus x, and the denominator is the same, x plus 2 times x minus 1. Now we can simplifying the numerator. So the simplifying for this one, what is the simplifying? Who will help me? What is the final answer here? Combine like terms. Who will do combining the like terms?
3x minus x.
What again?
Plus 6. Wait,
3x minus x. What is it?
3x minus
What is this? The
so
combining?
2x. 2x
What's the answer?
plus x squared.
2x. Okay. Plus 6. What is the 6? Again,
Plus 6.
the x. Yeah. So you add the 6, right?
Yeah.
Okay. So yes, this is correct. So we're adding the 3x with this x, I get 2x, and the x squared, it's by itself. We don't have anything, so x squared. And here we have the 6 left. There is no numbers we can combine with the other numbers. So this is correct. X squared plus 2x plus 6. Yes, Eric and Maisha. This is correct. Now the denominator, we keep it the same things, x plus 2 times x minus 1. And this is my final answer. Okay, is it clear how to find the least common denominator and how we can adding two fraction? Anyone has like question or confused in some part of this question in this example? Okay, so I'm going to give another example, like to make sure you understand how we adding a fraction. So another example here, example 2. So the example is find the sum of 2 over x plus 6, and here I have 1 over x squared minus 36. So 2 over x plus 6 and 1 over x squared minus 36. So here we have add. Now, first step, we have to find, like I said before, the least common denominator. So here, the least common denominator. Now, what is the factor of x plus 6, the denominator of this fraction? What is the factor of x plus 6?
The same thing.
Same things. It's factor already. And what is the factor of x squared minus 36?
X plus 6, x minus 6.
Yes, this is correct. X plus 6 times x minus 6. This is called the difference of square. We talked about this last time. I gave the property of the difference of square. The first term minus the square root of the second term. I mean the square root of the first term minus square root of second term times the square root of the first term minus square root of second term. So x plus 6, x minus 6. Now we cancel the common between the two factors. So here I have x plus 6. So this is canceled with x plus 6. Here after I cancel, the thing it's remained is 1, is not 0. Here the remaining is 1, not 0. I can't see 0. So here is remaining 1, and here the remaining is x minus 6. Now, what I have to multiply this fraction? By which?
X minus 6.
X minus 6, this is correct. I am multiplying this fraction, both of the numerator and the denominator, of the factor of x squared minus 36, and is x minus 6. So here x minus 6. And here is x minus 6. And what I have to multiply the second fraction?
1.
By what? exactly by 1. So here we have to multiply by 1, multiplying everything by this different color by 1, and here multiplying by 1 by this one. And I mean for the green, for this one, x minus 6. So now the final answer gonna be, I mean, like I have to simplify after a multiplication. So now I can get here. So here, first of all, I have to distribute inside the parentheses. So distribute the 2 inside this parentheses, 2 times x and 2 times 6. So what I get? What is 2 times x and 2
Get
times
to
minus 6?
minus 12.
Yes, it's 2x minus 12. And here I get x. Now, x minus 6 times x plus 6, what they give me?
X squared minus 36.
X squared minus 36 is correct. And for the second fraction, they give me 1 over, because anything times 1, they give me the same thing, over x squared minus 36. So both of the denominator are equal. Look to the both of the denominator. Both of them are equal. X plus 6, x squared minus 36, and the other one is x squared minus 36. And here's some. So the both of the denominator are equal. So I'm using the property of the first thing here. If I have a over c plus b over c, the denominator are equal. So I just adding the both of the numerator, both sides. So what is the adding for the numerator here in both fraction?
2x.
2x.
Wait, hold on. Why is it minus 16 instead of minus 12? Like, x minus 6 times 2 is supposed to be 2x minus.
Oh, 12. Hold on. Oh, something wrong here. Here's 12 too. Because 2x minus 12. Yeah, this is correct. Go ahead.
Yeah, so 2x
2x
minus 12 plus 1, that's minus 11.
plus 1.
Yeah, plus 1.
So this is minus 11, yes. And here I can get x squared minus 36. So the final answer is 2x minus 12 plus 1, it's minus 11 over x squared minus 36. Any question on this example?
You still have to factor the denominator into x minus 6.
No, we don't need it.
Because
we don't
the
need.
question is factor.
Okay, you can factor it or you can keep it the same like this. So if you want to factor it, you can make it as equal 2x minus 11 over x minus 6 times x plus 6. Here's the answer too. So you can write it as this or as this. Again, here is minus 6. Here I get a question. Is not 2x minus 12? Yes, it's 2x minus 12. Joel, it's 2x minus 12. Because 2 times x, 2x, and 2 times minus x, 6 is minus 12. In 1 second. Okay, any question for this example? No? Okay. Now, another thing in this section is how to compound factor. Compound factor. I mean, for this one, if I have a fraction, this fraction, both of the numerator and denominator, they have another fraction. So we need to simplify this fraction in the numerator and the fraction in the denominator such that we combine all the fraction to one fraction. I mean, is fraction which both of the numerator and denominator are fraction expression. Okay, so I give example for what I said here. So the example is suppose I have, so the question is simplify x over y plus 1, and here I have another fraction 1 minus y over x. So I have actually fraction over fraction. So how we can do this thing? So I'm going to do this one step by step. First of all, I have to rewrite this fraction as x over y plus 1 inside parentheses dividing by the second denominator, the fraction in the denominator, 1 minus y over x. This is the first step. Second step, we have to simplifying inside the parentheses here. So actually this is 1. So the 1 this here 1. So actually this is 1 over 1. Now for adding fraction, so we have to make the denominator are equal. So how we can make the denominator equal here in both inside this parentheses? So to make the denominator are equal, we have to multiply this fraction 1 over 1 by what? By y for both sides. And the same thing here. This is actually over 1. So I have fraction, like fraction adding by other fraction, the same idea like here inside parentheses. So to make the denominator are equal, we have to multiply both sides here in this fraction by x. So times x times by x times by x times by y times by y. So now I can get x over y plus y over y in the second fraction dividing by x over x minus y over x. Here I get a question, I'm confused. So again, I'm going to simplify, repeat what I said. So if I have, for example, fraction in the numerator and another fraction in the denominator, my goal here or my idea is to make all this fraction as one fraction. So first of all, we have to rewrite these things as x over y plus 1 inside parentheses. I change this fraction as dividing sign. Then I have to rewrite these things again, 1 minus y over x. So just I rewrite it everything in different way. Now here I have 1. So I should make the denominator r equal to do sum of the two fractions inside the parentheses. So I have 1 over 1. So to make the denominator r equal, so I should to multiply this y and the denominator by y and the numerator by y. Here in this side, I have to multiply this both sides by x because the denominator here is x. Now this is equal. We have to do sum of the both of the numerator because the denominator are equal is y. So I can get x plus y over y dividing by x minus y over x. Now here I get the question, you don't have to flip the sign. Yes, I'm going to flip it right now. So here this is equal this fraction x plus y over y. Now this dividing, I have to flip it to multiplication. Now flipping this fraction as x over x minus y. Now, because we have the same, because we have multiplication, so we can multiply. So this is mean we multiply the numerator together and the denominator together. So now can I get x plus y times x, and here I get y times x minus y. I can distribute inside the parentheses and simplify it more. So x, so here I can simplifying by distributing this x inside the parentheses and this y by inside the parentheses. So now can I get x times x squared plus xy over y times x is xy minus y squared. Any question for this example?
Can you cross out the xy, both xy's? Because you have one in the numerator and one in the denominator.
Can we simplify further? It's like
No, we cannot.
right?
We cannot. No, we cannot. Like Ahmed said, we cannot cancel the x squared with the x with x or y with the xy here by xy. This is not correct. We cannot simplify it more. We cannot cancel this xy by xy because here we have sum in the front. And
Oh,
here we
yeah,
have,
it's not minus, so okay. Thank you.
that's why. Because here we have sum, so we cannot cancel this one. But if we have multiplication here and here we have multiplication, so we can cancel xy by xy. But because we have sum here, x squared plus xy, and here xy minus y squared, we cannot cancel the xy with xy. No, this is not correct. We can cancel xy by xy and just only when this sign here multiplication and this sign instead of minus multiplication. Any other question? So we have the last things here. We have some avoiding common error. There is a common error. We should to avoid it. Avoid common errors. So if I have x a times b, everything squared, this is equal a squared times b squared. This means I can distribute the exponent 2 inside the parentheses, a squared times b squared. But this is not correct for addition. A plus b squared is not equal the first one square plus the second one square. This is not correct.
You have to expand it.
So what we have to do? What is the a plus b square?
It's simply a plus b times a plus b
A plus b
equals
times
A
a plus b. This is
It's a
correct.
squared
And what is
plus
that
2
called? Plus 2.
plus 2ab plus b squared.
Yes, this is correct. This is called the perfect square. We talked about this one last class. A plus b, everything squared. This is equal the first term squared plus 2 times the first term times the second term plus the second term squared. So actually a plus b, everything square is not like multiplication, the first term plus the second term square is equal the first term square plus 2 times ab plus b square. Another common error we should to avoid it is the square root of a times b. For multiplication, this is equal to the square root of a times the square root of b. But this is not correct. This is not correct for addition. This is not correct for addition. I mean, for that, square root of a plus b is not the same as square root of a plus square root of b. This is not correct. Another one here, but ab over a, this is equal b. Why? I can cancel the a with the a. This is equal a. But for addition, a plus b over a, this is not correct. Any question for this? Okay. Another one is a squared, a to the power minus 1 times b to the minus 1. This is equal ab, everything minus 1. But this is not correct for addition. A squared a to the minus 1 plus b to the minus 1 is not equal a plus b minus 1. We should to know this, and we have more like two more, but this is the most important to show. It does not apply to just only of multiplying. You can cancel out. Yes, we can cancel out here only for multiplying. This is not correct for adding or subtracting. So this is the last things in this section. Now let's go over equations. P.8. P.8. First thing in this is called solve basic equations. So we're going to start over the basic equation, the easy equation, then we're going over more harder equations. Yes, I can go back to the previous slide here. Here you go. First of all, what is the meaning of equation?
Two expressions equaling each other.
Yes, exactly. And what else you can define equation?
An
Yeah, this is
equation.
correct. So, yeah. What
uh,
else?
an equation has a set of answers that makes it true.
This is also correct. Yep. So like Shab, he said, two expressions are equal to each other. Like I can said, for example, this is expression 3, for example, 3 plus 5, this is equal 8. So here I have this as expression, and here is another expression, and between these two expressions there's an equal. So I can define equation as two statements of mathematical expression are equal. So again, this is statement of mathematical expression, and between this two statements there's an equal sign. About very important property, then we move slowly by solving basic and easy equations until they reach the hard equation. So here the first thing is properties of equation. So first of all, if suppose I have two mathematical statements are equal, suppose I have A equal B, here the first first property. Suppose I have two mathematical expression A equal B. So if I add the same quantity to the both side of this equation, I will get an equivalent equation such that A plus this quantity, the C, they will give me another equation is equivalent to the original equation B plus C. Again, if I add C, the same quantity for both sides of this equation, I will get another equation is equivalent to the original equation, to this one. And this is correct. If I add to both sides C number, the C is quantity number or any real number, then I will get another equation. This equation is equivalent to the original one, equivalent to this one. Example 2, property number 2, the same things for multiplication. If I have an equation A equal B, and I would like to multiply both equations by the same quantity, multiplying by C for both sides, I will get another equation, another equivalent equation is A times C. This is equal B times C. So I will get another equation such that the other equation is equivalent to this one. But here we should to know the C must be not equal. The number C, not equal to 0. Here the C is not equal to 0. Because if it's equal to 0, will not be correct. It will not be an equation. Now, the first things in this section is solving linear equation. So we're going to start over linear equation. So solving linear equation. Linear solving equation in one variable. So we're going to talk about linear equation in one variable. So what is the meaning of linear equation? Any idea of linear equation? What is the meaning of linear equation?
It's an equation that represents a constant rate of change.
So yes, it's equation, but this equation, like what is the degree of the variable inside this equation? What is the highest degree of
Single
this
degree.
Will be 1, right?
Yes, a single degree. First degree.
What do you mean? What do you mean? Single first degree, exactly. So so I can define it here as an equation, like Shop said, is an equation of the form like ax plus b. So here a and b, both of them are real number, and the variable x, the x is a variable raised to the power 1. Raised to the power 1, single degree, or has highest degree is 1. So anything of equation of this form, ax plus b, is called linear equation. So we're going to talk about equation in the beginning. In this section, we're going to go over equation of, first of all, we're going to solve an linear equation. So in the beginning, we have to know some example. I will give you example to decide which of this following is linear equation. So here, the example, next slide. So the example is, which of the following is linear equation? So suppose I have 4x plus 5 equals 7. This is number 1. Number 2, 2x plus 1 half. The second one is x squared plus 2x equal 8. And the third one is square root of x plus 6x. Question is the first one, the first equation, is a linear equation?
Yes,
Yes.
How do you know?
because it's a first degree equation.
Exactly, because this equation, first of all, has the highest degree is 1. The variable here is x, and the highest degree is 1. So this is an linear equation. And also it's look like it's is an equation of the form in the form ax plus b. How I get this one? Because I have 4x plus 5. If I subtract 7 from both sides, I will get 4x plus 5 minus 7 is minus 2 equals 0. So I can get a linear equation. For the second, so this is correct. This is correct. This is a linear equation. Now for the second one, is it a linear equation?
No. Because it's a
It's
second
not
degree
a
equation.
linear.
It's
Exactly.
a parabola.
Yes, go ahead. Yes, a parabola. No, this is a parabola. Yeah, exactly. And also because we have the second degree of raising to the variable. So the variable here, x, raised to the power 2. So this is not linear equation. What about the third one?
Also no, not a linear.
So it's not a linear. Why?
Because a equals to 0.
Because a equals 0. What about this variable? Raised to which power?
Second.
Second degree.
It is this. If I need
1
to
over 2.
rewrite this equation, I will write it exactly x raised to power 1 over 2 plus 6x equals 0. So this variable raised to the power 1 over 2, and this is not correct. The linear must has all the variable here raised to the power 1 only. So this is not a linear equation. Okay, so after we know a general idea how we can decide this equation is linear or is not linear, now we can go over the example how to solve the linear equation. So example, solve a linear equation. So suppose I have 7x minus 4 equal 3x plus 8. So to solve something like this, I prefer to move all the variable to one side and all numbers to the other side. To solve something like this, I prefer to move all variables to one side and all numbers to the other side. I mean, for variable, this is a variable 7x, and this is also 3x. Eric said we minus 3x and 4. Yeah, this is correct. So to move this one, the 3x to this side, I have to subtract from both sides minus 3x. So minus 3x, minus 3x. So 7x minus 3x, what I get? This will be 0. They cancel each other. Now for the other side, 7x minus 3x. What is the answer? Four x. This is correct. Yes. So the answer is 4x. So now can I get 4x minus 4 equal 8? Now I need to move the number from this side to this side. What I have to do? How can I move the number -4 from this side to this side? Adding 4, exactly. So if I add 4 for both sides, I will cancel the 4 from this side. So here I can get 0. And now I get here 4x equal 12. Correct, Eric? Now what I have to do, I need x equal.
You just
I need
divide
x equal.
4 on both sides.
Yes, exactly. So I dividing 4 from both sides. So I dividing here by 4. We divide by 4 and here by 4. After I dividing by 4, what I get? X equal 12 over 4. And this is equal to 3. So x equal 3. This is the answer for this linear equation. Now, sometimes we have, like sometimes the question asks you, also after you find the answer, please go and check your answer. So how you can check your answer? If it's
So-
the variable x equal 3 or not?
So simply plug in substitute 3
To
for
check-
x in the original equation, and they should both equal to 23, I think. No. 27
Yes.
minus
So to check this is a
27.
correct answer,
18,
you
I
have to
think.
plug this variable x equal 3 inside this linear equation. So here 7 times 3 is 21 minus 4, they give me 17 in this side. Now you go back, you go to this side, you plug the 3 inside the variable. 3 times 3, they give me 9. 9 plus 8, they give me 17. So in this side is 17, and in this side is 17 after I plug the 3. So the 3 is an answer for this linear equation. So this is correct. So the 3 is an answer for this linear equation, because after I plug it inside the equation, they give the same answer. Yeah, this is correct, Chop. Minus 7 times 3 minus 4, they give me a 17. And the same thing for the other side, 3 times 3, they give me 9. 9 plus 8, they give me 17. So on the both sides, they give the same answer, 17. So this is mean the x equal 3 is a correct answer for this equation. Another example. Any question before we move to the next slide? Makes sense how you can solve a linear equation? Okay, so the question is, the example is, solve 3 over 4 x minus, not 3 over 4, x over 6 plus 2 over 3 equal 3 over 4 x. How we can solving something like this? Like I said before, we're moving all the variable to one side and all numbers to the other side.
You can't. I remember one way I did it before was just simply multiply everything by the least common multiple.
Yes, you can do this, or you can do the step. The least common multiple here is 6
12, I
and 3
think.
and 4 is 12. Yes, this
Yeah.
is correct. Then multiply everything by 12.
But you can move everything to one side and simplify that way as well.
Exactly, exactly. So I'm going to move everything to all the variable to one side and all the numbers to other side. So I'm going to move the x over 6 to this side. What I have to do to move this one to this side?
Subtract 1/6 x
by-
on both sides.
Yes, so I have to subtract both sides by x over 6 or 1 over 6 x. So here subtracting by 1 over 6 x. Now this canceling each other, cancel out. So now I get 2 over 3 equal, if both sides do not simplify to the same number, that means you are did something wrong. I was going to, yes. Now I get here 2 over 3 and 3 over 4 x minus 1 over 6 x. So again, I have to simplify this side. So this is equal 2 over 3 equal 3 over 4 minus 1 over 6 times x. Now I have two fractions. Fraction 3 over 4 and second fraction is minus 1 over 6. So
Least common
if I have
multiple
two
is 12.
fractions, the least common multiple, or we can multiply, do a cross multiplication. Cross multiply to solve this. Why? Because the denominator here is 4 and 6. They are not equal. So the best idea is to make the denominator are equal. We have to do the cross multiply or finding the least common denominator. But I prefer to do the cross multiply. So 3 times 6, they give me 18. 4 times minus 1 is minus 4 over 4 times 6 is 24 times x equal 2 over 3. Now let's simplifying the inside the parentheses. So here I can get 2 over 3 equal 18 minus 4 is 17. Is 14. Is 14 over 24 times x. Now we can simplify this one, the 14 and 24 by dividing both sides by 2, right? If I divide the 14 by 2, what I get by 2? What I get if I'm dividing the 14 by 2? Eric, yes, this is correct. 7 over 12. That's correct, because if I divide the 24 by 2, they give me 12 too. So now here I get 2 over 3 equals 7 over 12. 7 over 12 times x. Now, how can I remove the 7 over 12? What I should do now to get the x only? What is the step now? 2 over 3 equals 7 over 12x. I need x equal.
You divide.
Dividing, or what I have to do? Dividing by 7 over 12. This is correct. Or I have to multiply by what? This is correct. Dividing by 7 over 12 or multiplying by the reciprocal. What is the reciprocal of this one?
12 over 7.
12 over 7. So here multiplying by both sides by 12 over 7. So 12 times 2. So I get now 2 over 3 times 12 over 7 equal x. So actually my x equal, if I simplifying here, 3 with the 12, I can simplify the 3 with the 12. The 3 is 1, and the 12 is 4. 4 times 2, they give me 8/7. And this is my final answer. Any question for this one? So just you have to follow the step, because we have fraction here is a little bit confusing, but if you're following the step, you will get the answer. Again, you're subtracting, you're moving the x to one variable and the number to the other variable. So I subtract x/3 from both sides. Now this is left 2/3 equal 3/4x times 1/x 6x. Now we factor this. So I get 3/4 minus 1/6, everything times x. Now, because the fraction is not, the denominator are not equal, so I try to do the cross multiply, but some students, they said we can find the least common denominator, but I prefer the cross multiply because it's easier in this step. So 3 times 6 is 18, 4 times minus 1 it's -4, over 4 times 6 is 24. Now I get here 2/3 times this things inside the parentheses times x. Now the inside the parentheses, I get 14/24. I can simplify it more and more, dividing both sides by 2. I get 7/12. Now I multiply both sides by the reciprocal 12/7. So I get 2/3 times 12/7 equal x. I simplified again 3 with the 12. 3 is 1, the 12 is 4. 4 times 2 is 8/7. And this is my final answer. Where you get the 24? Eric said, how I get the 24? I get the 24 by multiplying the 4 times 6. 4 times 6, they give me 24. Yes, that's correct, Chop. Multiplying 4 by 6, I get 24.
I mean, I think we are more comfortable of just doing it, you know, how we find the least common multiple. And this is a total new way. I think that's why we are confused a little bit.
Yeah, you can. Okay, let's solve it in the different way by multiplying the
Yeah.
least common multiple. Okay, so here again, same question. Example, same example is 6x over x over 6 plus 2/3 equal 3/4x. The least common multiple between 6 and 3 and 4 is 12. Why? Because here the 6, if I divide it by 1, they give me 6. Divided by 2, they give me 12. Divided by 3, they give me 18. Same thing here, 3, 6, 9, 12, and so on. Here 4, 8, 12, and 16. So the least common multiple, the least thing are simple, is the 12, the number 12, because the 12 here is the same as 12 here, is the same as 12 here. So you're multiplying everything here, all the fraction, by 12. So now I can get this different way to solve this question. 12x over 6 plus 24 over, because 2 times 12 is 24/3 equal 12 times 3 is 36/4x. Now we can simplify it more. 12/6 is 2x plus this, we can divide it by 3 here, 3 here, I get 8. And 36 divided by 4 is they give me 9. And we can, so the equation here is the change to different way, but this is equivalent to this one. So now we're moving the variable to one side and the number to other side. So here I can get 8 equal, here subtracting by 2x from both sides. So I can get here 8 equal 9 minus 2, they give me 7x. Now dividing both sides by 7 to get the variable x. So here dividing by 7, dividing by 7. Now the final answer is x equal 8 over 7. Okay, any question for this one? But the important things you have to know, what is the least common multiple between the denominator for all fraction, between 6 and 3 and 4. Okay, any question for this one? Now, okay, if there is no question, now we're going over solving power equation. Here, solving power equation. Solving power equations. So another type of equation is the power equation. Okay, so this is mean the power equation here. The power equation x raised to the power n equal a has the equation x equal the nth root of a if n is odd. And x equal plus negative square the nth root of a if n is even number. And here a must be positive, and in the same time a must be positive or 0. Again, the power equation x raised to the power n equal a has the equation x equal, we take this the nth root for both sides. When I take the nth root for both sides here, I get x equal the nth root of a, and n here is odd. But if n is even, I have to take the positive negative, such that I get x equal positive negative the nth root of a if n is even, and I have to know a here inside must be positive if n is even. So it's easy and small example for this. Example, if I have one, I have x squared minus 5 equals 0. How can I solve these things, this equation? First of all, is it a power equation? is it a power equation? I mean, I can write it of the form x to the power n equal a for any integer n. Yes or no? Is it a power equation?
Um,
Can
wait,
I write it?
what's the question?
Yeah.
Is this example here x squared minus 5 equals 0 is it a power equation? I mean, can I write it of this form x to the power n equal a, whatever n is?
Yes, I think you can.
How?
Isn't it n becomes 1/2 square root of x, something like that?
No, can I write this equation like this exactly? X to the power n equal a.
Can you add 5 on both sides? So it's gonna be
Yes, okay, let's adding 5 for both sides. What I get?
you get
X squared equal what?
5.
5. So x squared equal 5 is exactly similar to this one.
Yeah.
So this is a power equation.
And then you could just square root on both sides.
Yeah, take the square root of both sides. So I get x equal, because this is even or odd. Here the 2 is even. Yes, Ahmed. Is it even or odd?
It's even.
Even. So which one I have to use? The first one or the second one?
The second.
Second. So I have plus negative the square root of 5. I use the second one because n is even. The n here is 2. So it will be plus minus square root of 5. This is the answer. Any question for this one?
It's like isn't it like the quadratic equation where it
example.
shows? Oh, never mind.
It's look like quadratic equation. It's look like a difference of square equation. X squared minus 5, because I take this, like I can solve this one in different way. Who will give me the different way for solving something like that? We take the property for this one in the in the previous class. Can you give me a different way?
I would actually factor it.
Factor it. How you can factor this one?
A number that's multiplied and gives me 5 and subtracts equal to 0.
So what I have to write here?
Multiply equals 5.
Multiplying equal, like, what about if you factor x squared minus 5? How you can factor?
Wait, what?
How you can factor x squared minus 5?
X plus 5 and x minus 5.
X minus 5 or the square root of 5? Actually, we're taking the square root of this and this. So x minus square root of 5 times x plus the square root of 5. And this is equal 0. And to solve equation like this, we make this one equal 0 or the second one equal 0. So x equal x minus square root of 5 equals 0, or x plus square root of 5 equals 0. And now we solve this equation by adding square root for both sides. So I add here square root of 4 for both sides. Now I get here x equal square root of 5, or I subtract square root for both sides. So I can get here x equal the minus square root of 5. And the same answer, x equal the positive square root of 5, or x equal the minus square root of 5. The same things here. X equal the square root of 5, the positive, or the negative 1. This is another way to solve this equation.
But didn't you teach us that when it says like x squared minus 5, that's called difference of squares?
Yeah, this is called difference of squares. So when you do this difference of square, you open two parentheses. In the first parentheses, you take the square root of the first term is x, and and you put the minus, and the square root of the second term is square root of 5. And the same things for the other parentheses, but the difference is the sign. Instead of minus, you put the positive. I gave you the definition last time, but we use it for like a complete square, like x squared minus 9, because x squared minus 9 will not take the square root, because the square root of 9, they give me 3. So I was talking about x minus 3 and x plus 3, but this is like more a little bit harder than the other example we gave from last time.
Oh.
Now, example number 2. If I have x minus 4, everything square, equal 5. How can I solve this one?
You
Yes, sure.
can, I think you can square root both sides.
Take the square root for both sides.
I
Take
think that's one way of doing it, maybe.
So what is it? It's
So
taking
when
the
you
square root.
Yeah, when you take the square
Yes.
root of both sides, that square root
This correct.
cancels, and then that
Correct.
equals to x minus 4 equals the square root of 5,
Yeah.
and then you add 4 on both sides. So it's
So I
just
take the square root of both sides, but this is even or odd?
that's
The
odd. So it's gonna be a
No, number 2 is even or odd?
number 2 is
Is
it's
even. Even.
okay.
Why that even is 2, 4, 6, 8, 10. All these numbers is even.
Mhm.
And the odd is 3, 5, 1, 3, 5, 7, 9, 11, and go ahead is odd. So because this is the 2 is even, we go back to the property, we have to take the positive, negative. So here, positive, negative. Now what we should to do, Shop, after that?
So x equals 4 plus the square root of 5, and then 4 minus square root of 5. X equals 2 solutions. I
Yes,
think.
so exactly. So here we have to add the 4 for both sides, right?
Yeah.
To cancel the 4 from this side. So now I get x equal the positive 4, positive negative square root of 5. So actually I get two answers. The first answer, x1 is equal 4 plus square root of 5. And the second answer is x2 equal 4 minus square root of 5. Make sense? Any question?
Professor, could we leave our answer
Yes.
just as like, well, 4? Okay, never mind then. Yeah.
Yes, you can leave the answer like this only. 4
Okay.
plus negative square root of 4. So you can leave the answer like this, or you can leave it like x1 equal and x2 equal. The last thing in this section is how to solve for one variable. solve for one variable. Let's go to the next slide. Here, solve for one variable. So what I mean for this, here example. Here's example. The question is solve for the variable, solve for the variable m, I mean capital M, in the equation f equal g times small m, capital M over r square. So actually the question asks how we can write this thing f equal g times m capital over r square as m capital equal something. So how we can move everything to this side and we only leave this m alone and the other side. Who will help for this one?
I'll help you.
So my f again equal g. Yes, go ahead.
So that's r squared in the bottom, right?
Yes, r squared in the bottom.
So you multiply r squared on both sides to cancel it out on this side.
Nice. So first step, I multiply both sides by r squared times r squared. So when I multiply both sides by r squared, this and this cancel. So what I do next?
Now you can rewrite it r squared times
R
f
squared times f equal
equals
g
big.
m capital.
So now you can just divide g and small m on both sides and you're left with the big M.
Exactly. So dividing both sides by g capital M small, g capital M small. Then when I do this, this cancel. Now I get M capital equal R square times F over G M. And this is my answer. So now I get M equal R square times F over G times M. Or I can remove this here, this, and I can multiply as dot, both like that. So this M, I can write it as F times R square over G times M. Okay, any question for this one, for this example? No. Okay, so by this example is the last thing in this section. We're going to stop up to here for today. And next week is your first exam. And we're going to finish one more section next Tuesday. And Thursday is your first exam. All the details, I will send it in the Blackboard for the exam, like the room, the number of the room, the time of the exam, and all details will be on the Blackboard. Okay, have a good day. See you next week.